Hello, grade 12. We are back again. In today's lesson, we are looking at sigma notation, and without any further ado, let's just get right down into business. Right, so what is sigma notation? Sigma notation is just a way to represent the sum of the series. So previously on, we've talked about the sum of the arithmetic series, and then we've also talked about the sum of the geometric series. Now, sigma notation is just a convenient way to represent that sum. So this letter here is what we know as sigma, and then this is a Greek letter which stands for S, right? So the sigma notation represents the sum of the series. So whenever we are using sigma, that means we are faced with a series. It can be an arithmetic series, it can be a geometric series, but then we are trying to find the sum of that series, right? So, okay, what we have to understand about the notation of a sigma is that if you are given n, let's say is equals to I, and then right here you are given k, then here this will be tn, and then let's say is equals to s, right? Now the I there will be what we call the start index, right? So this is the lower value, the number that you'll be substituting first in order to get your A value, which means this is the number that you'll be substituting to get your T1. So that is the start index or the lower value. And then the Tn will be the general term, right? So this will be the general term of the series. So this is your nth term. So this is what will go in here. Most of the time we'll calculate the general term and then substitute it in here and put it in brackets. Now what is the S here? The S will be the sum of the series. So after you have calculated or after you have found the pattern, then you'd have to calculate the sum of the series. But then obviously in order to calculate the sum of the series, you'd have to know how many terms are you adding, which that's where K goes in. So K here is your end index, right? So the end index. So this is your upper value, right? Now, if you want to find how many numbers are there in the pattern or in the series, then all you have to know is for the number of terms, you'd have to say upper value minus the lower value, then plus 1, right? So make sure that you save this. So n is the upper value minus the lower value plus 1. So meaning in other words, you'd have to take the number at k and then minus the number at I and then plus 1, right? So that's essentially how you'd get the number of terms. Now, let's say, for example, you have a sigma notation like this, and then it's saying n starting from 1 and then ending at 10, right? And then we have our Tn as 3n minus 1. And then this is equals to, okay, so I'm not sure what sum it would give, but then I'm just predicting, let's say maybe 45, right? So if we wanted to find the number of terms that would be there, we would have to say n is equals to upper value minus lower value plus 1, right? Now we do know that it's obvious starting from 1 all the way to 10, that's 10 terms, because we'd have to say 10 minus 1 plus 1, and then this will give us 10. Even if you were to count, if you are starting from T1 and then followed by T2, then T3, T4, T5, T6, T7, T8, T9, and then T10, we can say that that's exactly 10 terms, right? But then what happens if now they change this one? Let's say now it's starting from n is equals to 0. Now at this point we can see that our number of terms will no longer be 10, because now to get the number of terms again we need to say upper value minus lower value plus 1. Your upper value is still 10, but then your lower value is 0, then plus 1. Then that means we are dealing with 11 terms, right? So why am I doing this? It is just a way to show you that this number here is not always will not always represent the number of terms. If you want to find the number of terms, you'd have to take this number, subtract by the lower number here, and then add 1, right? So again, it can also be in a case whereby we have this 3n minus 1, but then the n is now starting from 5, right? If we want to see how many terms we are dealing with here, obviously this is what you have to do again. So you can't say the number of terms are 10. You'd have to say n is equals to upper value minus lower value plus 1. And then this is going to be 10 minus 5 and then plus 1. Now 10 minus 5 will give you 5 and then plus 1. That's equals to 6. So we are dealing with 6 terms. So even if you can check here, if we are to start from T5, that's 1, 2, 3, 4, 5, 6 terms, right? So that's the first skill that you need to acquire when dealing with sigma notations. You need to perfect how to find the number of terms. Now, what does this all mean, right? What is the meaning of all this? Let's say we have our sigma notation again, and then let's say now starting from n is equals to 1 and then ending at 10. Let's just decrease the number and let's say it's ending at 6, right? Okay, then we still have 3n minus 1. Now, what this means is that if we are to expand this, expression, this means we have to start our n here. We have to start by substituting our n as 1, then followed by n as 2, then followed by n as 3, all the way until I get to 6. So in order to determine my pattern here, I would need to first start by 3 times 1 and then minus 1, which will give me what? 3 times 1 is 3 minus 1 is 2. Then to get the next term, this would be 3 multiplied by 2 minus 1. So this is 6 minus 1 is going to be 5, right? And then to get the other term, 3 times 3 minus 1, and then that's 9 minus 1. It's going to give me 8. And then all the way like that, 3 times 4 minus 1, that's 12, and then minus 1 is 11. Then we have 3 times 5 minus 1, that's going to give me 14, and then we have 3 multiplied by 6 minus 1, that's 18 minus 1, it's going to give me 17. So now I have created a pattern, and then if you can look at this pattern here, we can see that this is exactly an arithmetic sequence or an arithmetic series, because we are dealing with the sum, so it has to be a series. So now I have 2 to get to 5, I have to add 3. 5 to get to 8, I have to add 3. So we can see that this is an arithmetic progression. Now, in order to get the sum of this series, all I have to do is add the values of the 6 terms. So I would have to grab my calculator and say 2 plus 5 plus 8 plus 11 plus 14, then plus 17. And then when I add all that up, I will get 57, right? Now, this is what we call a sigma notation. So the n here is representing that I need to start substituting my n value by 1. And then from here on, I need to progress to 2, 3, 4, 5, all the way up until I reach the end index. So I cannot go beyond the end index. So if it ends at 10, I need to end at 10 as well. Then when I get all those, I need to then find my sum like this. But then remember, you do not have to add all of this. Remember, if this was 60 here, you wouldn't be doing all these numbers all the way up until 60. This is where now you have to consider that the minute you find that this is an arithmetic progression, you can calculate your sum again by using the formula n over 2, and then you have 2a plus n minus 1 and then d. So because now you'd have calculated the number of terms by saying n is equals to upper value minus lower value plus 1, you will say 6 minus 1 plus 1, which will give you a 6. And then at this point, you will say 6 over 2, and then 2. Your a value is the first term, right? So you'd put 2 there. And then you have 6 minus 1, and then your d value, that's the common difference that you find between the terms, which we did conclude that it was 3. Then you put your 3 here, and then you simply punch this into your calculator. Obviously, when you punch that into your calculator, it is supposed to give you the sum there. So we get 57, which is what we have here, right? So now, that means, what is it that you must know? You must, number 1, know how to get the number of terms. That's the first thing. So first know how to get the number of terms from using n is equals to upper value minus lower value plus 1. And then you need to write out at least 3 terms. So write out at least 3 terms. Now, the benefit of writing out at least 3 terms is to actually find out whether the pattern is arithmetic or geometric. At times you can find that it is quadratic, right? Then after you have written that out and then you found out if it's arithmetic or geometric, then you need to calculate the sum. You need to calculate the sum. And then just like that, you then write it in sigma notation, right? So now that sum that you have found there, you can then write it here. So in that way, you have found the value or the sum of the sigma notation or the series, right? So these are the steps that we'll be going through when solving these questions here based on whatever that they want. Sometimes they just want us to expand. Sometimes they want us to calculate the value or the sum of the series. So when we are dealing with the questions, you will see how I tackle these different questions. Okay, so let's just start with a few examples here, few basic exercises. Now, question 1 says determine the value. How do we solve questions whereby they say determine the value? What is it that they want if they say determine the value? When they say determine the value, that means they want you to calculate the sum of the series, right? Now, in this case, how do you do it? We are given the sum of the Tn is only 2, but then k is running from 1 all the way to 4. Now, we can see this is a bit complicated because we only have a constant here, right? But then this is what you need to know. Whenever we are given a constant, there is a rule of sigma notation that says if you are given a constant, let's say sum of k to 1 here, and then you are given an n value, and then this is a constant. Now they say the sum to that is simply just c multiplied by n. Right. Now, what does that mean? It means that what you have here, remember there is no k here to substitute in. But then in actual fact, there is a k. It's just that now the k is raised to the exponent of 0. So in actual fact, what you have here is 2k to the exponent of 0. Right. Now, if you start substituting your k from k is equals to 1, you do understand that if you have 2, and then 1 to the exponent of 0. Any number to the exponent of 0 will just be 1. So that means here, your first term will be 2. Even if you were to substitute for the second term, now you have your k as 2. Because 2 to the exponent of 0 will still be 1, you will still have your solution as 2. If you substitute your k as 3, this is to the exponent of 0, you still have your k, you still have this as 1, so 2 times 1 is still 2. And then the last term will be 2. Remember, the end index is 4. So this will be 4 to the exponent of 0. And then this would still be 2. So this is 1, 2, 3, 4. Now, what is the meaning of this? It means take the constant that you are given, multiply by the number that is up here, right? So in this case, the sum of k is equals to 1 all the way to 4. And then we have a constant 2 will just simply be that constant 2 multiplied by the upper value here, which is 4. And then this will give us what? 8. So if in doing it like this, this is 2 plus 2, which is 4, plus another 2, it's 6, plus another 2, that's equal to 8. Right? So that means, in other words, when writing out this one, you will say k is equals to 1, running all the way to 4, for 2 is just equal to 8. And then you are done. You have found the value. So that's all that you are supposed to do. So make sure that you note this. The one rule that you have to notice this. Whenever you are dealing with a constant here, then you simply just take the number over here, multiply by this. But then you have to be careful. It has to be running exactly from k is equals to 1. Right? If it's starting from anywhere else, then there is also a certain rule that you need to note. But for now, NB this rule here. This is when we are dealing with a constant value, right? The sum of constant value. Sum of a constant value. So this is how you deal with the sum of a constant value. Now we have B. It says we have I running from -1 all the way to 3. Now this is pretty simple. We have sum from -1, and then we have I, and then ending at 3. So that means we have to start substituting our I as -1. Now that means since we only have I here, this means we'll have -1. Then after -1, we know what follows. It's 0. So all we have to do is -1 plus 0, then followed by 1, followed by 2, then followed by 3. Then all you have to do is simply just grab your calculator and punch all of that. So -1 plus 0 plus 1 plus 2 plus 3, then this is going to give us 5. So that means in writing out this one, you will just say I is equals to -1 running up to 3 for T and I is equals to 5. Then you are done. So that's how you find the value there. So we can see that when we want the value, the first thing that we have to do is expand the series. Okay, then we have C. How do we deal with C? Again, we have n is equals to 2, and then we have 3n minus 2, and then 5 here. So this is running all the way from 2 to 5. Then first thing we do is expand. This means that we have to start substituting our n as 2. So to get the first term, it's 3. So note, it's saying the start index is 2. You can't start from 1. You can't start from 0. You need to start from the start index here, the number that is being indicated. So 3 times 2 minus 2, that will give you your first term as 3 times 2 minus 2, that's equal to 4. And then going to 3. Okay, we have 2 right here. So 3 times 3 is 9, and then minus 2, that will give us 7. And then now we have 3 times 4 minus 2. 3 times 4 is 12, and then minus 2, that will give us 10. Now we go to 5. 3 times 5 minus 2. 3 times 5 is 15, and then minus 2 is 13. So now what do? We simply add all of this. So 4 plus 7 plus 10 plus 13. And then we're going to get 34. So that means we have to write this one as equal to 34. And then that's our answer right there. Okay, so easy peasy. That's how we do it. That's how we do it. Okay, so remember, these are just basic exercises just to make you understand this. When it gets to exams, it's a whole complete story. Then, okay, we have expand the series. So careful with this one. For this one, we are only required to expand the series. So we are not supposed to get the sum, just only expand the series. Then k is from k starting from 1 all the way to 6. We have 0 is to k. So that means 0, we have 0 is to 1 first, followed by 0 is to 2, followed by 0 is to 3, 0 is to 4, and then 0 is to 5, and then 0 is to 6. Now, obviously, we know all of this will just give us 0 if we were to just get the sum here. But then we are only required to expand, so we leave it like that. Now, with this one here, again, we need to be careful, right? We have spoken that if we have a constant here, it's just a matter of noting that that constant is the same as having 8 and then n. Remember, we are given n. So it's that constant n to the exponent of 0, right? So this will just go 8 and then -3. So your n value, and then 0 here, followed by 8, to the exponent of negative 2. Remember, we must start from negative 3 all the way to 0. So consulting your number line, that's negative 3, followed by negative 2, then negative 1, and then 0, right? So to the exponent of 0, 8, negative 1 to the exponent of 0, and then 8 all the way to 0, and then to the exponent of 0 like that. So we have expanded just like that, which if we are to further do this, we know that this should be 8, and then this should be 8 over here, and then this should be 8. But then this part here is undefined, right? So that means we'll only end up with 8 plus 8 plus 8, right? Which we are not supposed to find the sum of this. So we'll just simply leave it like that. It would be 24, but then this is only just a matter of expanding, right? So we know the only part whereby we are not going to get a solution is for this one, because 0 to the exponent of 0 is undefined. We have C. We have sum of K is equals to 1, and then all the way to 5, and then we have AK, right? So to expand this one, this is going to be K starting from 1, so this is A times 1, then plus A times 2, then plus A times 3, then plus A times 4, and then plus A times 5, right? So this will just be A, and then plus 2A, plus 3A, plus 4A, then plus 5A, right? So it's just expanding this. We don't need to get the sum here. So it's just expanding, showing that the terms will be A, 2A, 3A, 4A, and then 5A. Obviously, if you had to add them up, you'd add all of this up, and then you find the sum of the series. But then it's only just expanding. Okay, so I hope all of this now makes sense. Let's then proceed. Now, here they're saying calculate the value of A. We must calculate the value of A. Now, looking at this, we can see that we are already given the sum. Remember, what comes after the equal sign, we did speak that this represents the sum, right? So in this case, what do? We want to calculate the value of A, right? We can see that K is running all the way to 1, from 1 all the way to 3. So we can indicate this by saying, let's first expand. It's A times 2 to the exponent of 1 minus 1, followed by A times 2 to the exponent of 2 minus 1. Then followed by A to the exponent of 2, 3 minus 1. Now, if you punch that into your calculator, 1 minus 1 is 0. Any number to the exponent of 0 is 1. So we only have A here. And then here, 2 minus 1, that's 1. And then 2 to the exponent of 1 is 2. So this will be 2A. Now here we have 3 minus 1, which is 2. 2 to the exponent of 2 will be 4. So here this is 4A. But then remember, we are already given the sum. The sum of all of this is supposed to be equal to 28. So we can simply find the value of A by saying A plus 2A plus 4A. So 1 plus 2 plus 4 is 7A. Remember, the A here has a coefficient of 1. So it's 1 plus 2 plus 4. This is 7A, and then equals to 28. Then we can simply just divide both sides by 7, and voila, just like that, we find our A value. 28 divided by 7 is equals to 4. Right. So that's how you were supposed to do that. So first expand and then equate to the sum, which is 28. And then from adding all of this, you will find there's the 7A, and then divide both sides by 7. Okay. Then for B right now, we can see that the A now is here, right? So that means, in other words, we are trying to get the sum of the series, right? Because looking at this, we can see that the A here is in the position of the sum. So what do? Our J must run from 1 all the way to 4. So first we expand. So this is 2 to the exponent of negative 1, followed by 2 to the exponent of negative. So remember, the 1 here, we have a negative already here. So I'm just substituting my J as 1. Then here, followed by 2. And then here, followed by 3. And then the end index is at 4. So 2 to the exponent of -1 must give me 1 over 2. And then this must give me 1 over 4. And then right here must get 1 over 8. And then this must be 1 over 16. Now this is all equal to A, right? Is equal to the sum. Now that means the value of A, I simply just have to add all of this. 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16, right? And then adding all of that up gives me 15 over 16, right? So this is the sum right there. This is the sum right there. So that's how we solve that. Okay, so pretty straightforward, pretty straightforward. Then, okay, let's now see more questions. Okay, now we are required to write this in sigma notation. So with all the questions we've been doing, we can say that we've been given sigma notation, and then what we needed to do was to expand. Now, what if they give us the expansion, and then we are supposed to write the sigma notation? So also that is not a problem. We have 1 over 9 plus 1 over 3 plus 1 plus 3. Now, if you are supposed to write in sigma notation, the first thing that you have to be concerned about is how many terms are there? How many terms are there? Right. And then number 2 is what is the general term? Okay, number 3 also the sum of the series. So 3 questions. How many terms are there? What is the general term? And then what is the sum of the series? Okay, now start with your sigma. And then your n, always assume that it will run from term number 1, right? Unless stated otherwise. Now, how many terms are there? It's 1, 2, 3, 4. So if it's running from term 1, then it needs to end at term 4. As we can see, this is a finite series, right? Then in order to get our general term, because we have already answered this, how many terms are there? It's only 4 terms, 1, 2, 3, 4. So we say n starting from 1 all the way to 4. Even if we say upper value minus lower value plus 1, we will still get the 4. So it's 4 minus 1 plus 1. This will still give us 4 terms. So we have answered the first question. The second question is, what is the general term? Now, to get the general term, obviously, we need to observe, is this an arithmetic sequence or a geometric sequence? Now, a quick analysis of the common difference and the common ratio will give you that. If you want the common difference, you'd say T2 minus T1, which would give you 1 over 3 minus 1 over 9. Now, 1 over 3 minus 1 over 9 gives you 2 over 9. Will it be consistent with T3 minus T2? Now, if we say T3 minus T2, if we say 1 minus 1 over 3, let's check. So this gives us 2 over 3. Now, the two values are not the same. So that means this is not an arithmetic sequence. Now, let's prove if it is a geometric sequence. Now, with a geometric, we'd have to say T2 divided by T1. Now, our T2 is 1 over 3. If you divide that by 1 over 9, you simply just grab your calculator and punch that. 1 over 3 divided by 1 over 9. We get 3. Now, let's see if it's going to be consistent here. If we say T3 divided by T2, this is going to be 1 divided by 1 over 3. Now, let's check again. 1 divided by 1 over 3, we get the value 3. So this has a constant ratio. If it has a constant ratio, that means it is a geometric series. So it is a geometric series. Now that we know that this is a geometric series because of the constant ratio, we know the formula that we have to apply for the general term is Tn is equals to AR to the exponent of n minus 1. Our A value being 1 over 9, then our R value being 3, and then to the exponent of n minus 1. Now, there is a way in which we can write the 1 over 9 in terms of base 3. we can say this is 3 to the exponent of negative 2, and then 3 to the exponent of n minus 1 like this. Because the bases are the same, we know that we can just add the exponents. This is just n minus 1, then minus 2. So it's 3n minus 3, right? So that's it. So that means this is the Tn that we are going to have here. 3 to the exponent of n minus 3, right? But then again, we are not done with our sigma notation. Remember, our sigma notation needs to represent the sum here. So what is the sum? This is the third question that we are going to answer. So we have answered what is the general term. The general term is our Tn, 3 to the exponent of n minus 3. Now, the last question is, what is the sum of the series? In order to get the sum of the series, all you have to do is add all these 4 terms that you are given here. So you will say 1 over 9 plus 1 over 3, then plus 1 plus 3. Then we find our answer as 40 over 9, which we need to take the 40 over 9 and put it here. Now, just like that, we have represented the sigma notation. Right, so we are done. Now, this is how you represent the sigma notation for a finite series. Right, so finite means that it comes to an end. You know the last value, right? You know the last value. Now, let's look at write the following series in sigma notation. If you are given 2, 7, 12, 17, then plus whatever values, that means this is an infinite or infinite notation, right? Or in infinite series. An infinite series, that means you do not know where it ends, right? Now, an infinite series would have to be calculated all the way to the n terms, right? N terms. So this is 2, 7, 12, 17, all the way to n terms. Now, how do we do this? 2 plus 7 plus 12 plus 17, then plus whatever. Then let's check. Number 1, we want to confirm whether it is an arithmetic series or a geometric series. Now, looking at this, we can tell that this obviously has to be an arithmetic, because if we can calculate our common difference, that's 7 minus 2, which will give us 5. Also, if we do 12 minus 7, this will still give us 5, right? So we have ourselves an arithmetic series. So where the d value is 5. Right. Now, in order to calculate the Tn, we'll say a plus n minus 1 d, where your a is now 2, the first term, and then n minus 1, then the d value is 5. So this will be 2 plus 5n minus 5, and then this will be 5n. 2 minus 5 is minus 3. Then Tn is 5n minus 3. Now, because we cannot be able to determine how many number of terms, remember I said the first question is how many terms are there? How many terms are there? Because we said this is an infinite series, we say there are n terms. Right. And then number 2, what is the general term? What is the general term? Now, the general term, we found it, it's Tn. Now, what is the sum of the series? Now, because we do not know the number of terms, that means it is impossible for us to know the sum of the series. So that means our sigma notation will just be represented in this format. So you can't know the sum of the series if you don't know how many terms must be added. So I must indicate n is starting from 1, but then it's ending at a k value, and then this being 5n minus 3. So the k here is representing the last term, the Tn, right? So n is starting all the way from 1, and then for the general term 5n minus 3, but then it's ending at a k value there, which is an unknown term, right? So which is an unknown term. Okay, and then that's basically how you would represent your sigma notation if you don't know the number of terms. So this is how you represent the sigma notation if you do not know the number of terms or where the series ends. Okay, now let's move to 1.2. Looking at 1.2, we are also given 5, 8, and then 11, and then plus 14. Again, this is an arithmetic series because as we can see, to get to the next term, we simply need to add 3. 8 plus 3 is 13. 11 plus 3 is 14. Right, so our common difference is 3. Again, we start with our sigma notation, and then we indicate n has to run from 1, but then has to end at a k value, which we do not know. So at this point, we need the general term. So Tn is equals to a plus n minus 1d. So a is 5 and then plus n minus 1, and then your d value is 3. So we are going to have 5 plus 3n minus 3, which will give us 3n. 5 minus 3 is 2. So our Tn is 3n plus 2, and then you simply just put it here. Then done. You have represented the sigma notation for that. Now we have 1.3. We are given 6 plus 3 plus 3 over 2, then plus 3 over 4. Right. Looking at this one, we can tell that this should be a geometric series, because if we are to find the common ratio, T2 over T1, this is going to be 3 over 6, which is going to be 1 over 2. And then if we do it for T3 over T2, we're going to have 3 over 2 divided by 3, which is still going to give us 1 over 2. So if you punch that into your calculator, 3 over 2 divided by 3, you get 1 over 2. So now we have what we call a constant ratio, which makes this a geometric series. So again, our sigma notation, n is starting from 1 and then ending at a k value there. And then here we have to indicate our general term in the format ar to the exponent of n minus 1. Our a value is 6, and then our r value is 1 over 2. Then n minus 1. Now there's nothing that we can do for this one. We can't write 6 in terms of any exponents. So we're just simply going to leave it like that. Remember, you can't say 6 multiplied by half, because this is a coefficient and this is a base, and you can't multiply a coefficient and a base, right? So here you're simply just going to write it as 6.1 over 2 to the exponent of n minus 1. Then there you go, right? So you have written it in sigma notation. So it's quite very simple to write your sigma notation, guys. Then, okay, we have 1.4. We are given 5, 15, 45, 135. Again, we can see another geometric progression. So 5, 15, 45, and then 135. Now, what we need to note is T2 over T1 first. So 15 divided by 5 will give us 3. Again, if we can confirm with T3 over T2, this is 45 divided by 15, which still gives us 3, right? So now we have our Tn is equals to AR to the exponent of n minus 1. Our A value is 5. Our R value is 3. And then n minus 1. Again, you can't say 5 multiplied by 3. You simply leave it like that. And then write your sigma notation. N is equals to 1. And then here your Tn is just say 5.3 to the exponent of n minus 1. And then indicate k there, because we don't know to which term it will actually end. Right. Then we have our sigma notations just like that. So that's how you indicate your sigma notation, and then make sure that you actually check that out. Find a lot of questions that you can do, and then you'll master that. Okay, so let's then proceed. says number 5, write down the sum of the first 25 terms. So we can see with this one, we are given the number of terms. So meaning it is possible for us to find the sum. So write the sum of the first 25 terms of the series below in sigma notation. So now this is all the way up until the 25th term, right? So meaning that if we can just look at this, it's 11 plus 4, then negative 3, then negative 10. Let's check if this is an arithmetic progression. So if we do our common difference, that's T2 minus T1. T1, this is going to be 4 minus 11. So 4 minus 11 gives us negative 7. Let's see if the T3 minus T2 will also give us that. If we say negative 3 minus 4, still we get negative 7. So yes, this is an arithmetic progression. So minus 7 to get to the next term. Minus 7. Right. Then we have our sigma notation. N is running from 1 and then all the way to what? 25, because we are supposed to have 25 terms. Again, upper value minus lower value plus 1 will give us the 25 minus 1 plus 1 is 25 terms, right? So we are fine. Then here we know that we are supposed to indicate the general term. So Tn is equals to A plus bracket n minus 1d, where A value is 11. Then how many terms? Okay, so we are supposed to just have the general term here. Then D is negative 7, right? Okay, so that's 11 here, and then negative 7n, then plus 7 from negative 1 times negative 7. So this is going to give us negative 7n. 11 plus 7 will give us 18. So our general term is this. This is our general term that we are going to put in here. Negative 7n plus 18. But then remember, once we are given the number of terms, we know the number of terms. That means we still need to calculate the sum of the series. As indicated here, they said write the sum of the first 25 terms. Now, obviously, we would not expand this, right? We saw with the other questions we were expanding and then adding that. But then we can all agree that it would be tiresome to expand this to 25 terms. So you'd have to say negative 7, 1 plus 18, and then do it all the way like that up until you get to 25. Now, this is too much, right? This is too much. So what do we do? The fact that we know that this is an arithmetic progression, it means that we can use the formula now. Sn is equals to n over 2, and then 2a plus n minus 1d. So what am I saying? You can expand for as long as the terms are just countable terms, like there are only like 5 terms, 6 terms. But then in a case whereby you have like 25 terms or more than that, then obviously you would need to consult your formula. All you have to identify is whether the series is arithmetic or geometric, and then use the relevant formula. Now, how many terms are we dealing with? 25 over 2. And then we have 2, our A value. So in order to find our A value, we consult the series there. So it's 11 plus, and then here we have 25 minus 1. Our D value, remember we said it's negative 7. Now all you have to do is punch all of this into your calculator. So 25 over 2, and then 2 times 11 plus 25 minus 1 in brackets, and then multiply that by negative 7. Then this will give us what? Negative 1,825 is your sum. Then you write it here, negative 1,825. Then just like that, you have found the sum of the first 25 terms of the series below in sigma notation. So that's your sigma notation. Voila, voila. Okay, now we have question 6, which is a bit tricky. It says write the sum of the first 1,000 natural odd numbers, right? Now, what are natural numbers? We know natural numbers are any numbers from 1 all the way up until whatever number infinity there. So, but then all the numbers starting from 1 to no negative values here. Then write the sum of the first 1000 natural odd numbers. Now, what is an odd number? So this is mostly on language, right? An odd number is a number that is not divisible by 2. So basically, any number that you'd have to divide, if you divide by 2, it will leave a remainder. So what numbers are those? It's your 1, it's your 3, it's your 5, your 7, your 9. So you get the whole drill, right? So those are your odd numbers. Now they want the sum of the first 1000 natural odd numbers in sigma notation. So the first 1000 numbers, if we were to look for odd numbers between 1 to 1000, right? Now we do understand from 1 to 1000, there will be 500 odd numbers and as well as 500 even numbers. Now, even numbers are the ones that will be divisible by 2. So these ones are divisible by 2. These ones are not divisible by 2. Right. Now, between 1 to 1000, there are 500 odd numbers, but we are looking for 1000 odd numbers. So that means we have to increase our sample space from 1 all the way to 2000. Right. Now, if there are 500 odd numbers between 1 to 1000, that means if we increase our sample space by another 1000, we are supposed to have 1000 odd numbers from 1 to 2000, and then also 1000 even numbers. Right. So, but then the odd numbers here, they will create a pattern. Right. So there's a pattern that will be created by the odd numbers. That's 1, followed by 3, followed by 7, followed by 7, 1, 3, followed by 5, and then 7. And then the last term, if we have to end at 2000, if we have to take from 1 up until 2000, the last odd number that we are going to have here, we can all agree, it's 1999. Right, which is just a unit before 2000. So now these numbers here will be creating a pattern. Right. What kind of pattern will be created by these odd numbers? This pattern is an arithmetic pattern because, as we can see here, to get to the next term, we simply need to add 2. So 1 plus 2 is 3, 3 plus 2 is 5, and then 5 plus 2 is 7, all the way like that until we get to 1999. Now we are supposed to get the sum of that. Obviously, if you had an infinite page, a very, very big page, you'd have to write all this up until you get to 1999, busy skipping 222. So you write all those odd numbers until they're 1000. Now you do agree that that would be tiresome, of course. But then since now you've identified that this is an arithmetic series, we can then use the formula that goes Sn is equals to n over 2, and then 2a plus n minus 1, and then d, right? And then your number of terms, how many number of terms are we dealing with? 1000. So we're going to put 1000 here over 2. Then our a value, meaning the first term, the first value to be odd here will be 1, right? As we can see from there. And then we still have the 1000 here minus 1, and then d is 2. Now, if you punch all of this into your calculator, so quickly it's 1000 divided by 2, and then 2 times 1 plus 1000 minus 1 in bracket, then times that by 2. So we're going to get 1 million, right? So the sum of the first 1000 odd numbers will give us 1 million. Right. Now, you can also do this because you know the last time, you can also do this by using this formula here, A plus L, right? And then you say 1000 over 2, and then your A value is 1, and then here you have 1999, right? And then if you punch that into your calculator, also this is supposed to give you 1 million, right? So either way, you can either use this formula or use that, because already you know the last term, you know the last value to be odd, there will be 1999. So now you have determined the sum of the first 1000 natural odd numbers, right? But then remember, we are not done. Remember, this must be written in sigma notation. Let's not forget the purpose of all this. Sigma notation. So, representing this in our sigma notation, we will have our n starting from 1 and then running all the way to 1000, right? And then here, what are we supposed to have? We are supposed to have the general term, right, of which we haven't calculated yet. What is the general term? What is the rule that governs this? This is Tn is equals to a plus n minus 1d, right? Our a value was 1, and then we have n minus 1, and then d is what? Is 2, right? So this is supposed to be 1 plus 2n minus 2. So this is supposed to be 2n. 1 minus 2 is negative 1, right? So at this point, we are going to indicate 2n minus 1, and then this will give us a sum of 1 million. If we are starting all the way from 1 to 1000. So our sigma notation is now in this format. So now we have seen that. So the most important thing is to know the number of terms, is to know the general term, and then is to know the sum. As we have discussed those questions that you need to answer when it comes to writing the sum of the series in sigma notation. Okay, so let's proceed. Now we have an extract from an exam paper. We are told to evaluate the sum of 2n minus 4 starting from n is 4 all the way to 70, right? Now we can see that we are working with a lot of numbers here. So we can't expand this all the way up until that end index there. So what do? We are supposed, when it says evaluate, that means we are supposed to calculate the sum of the series. We are supposed to find the value of the series. Okay, so what do? Remember, the one thing that you have to do is, I said you must write at least 3 terms. Now, these 3 terms will be able to tell you what type of pattern do we have there. Is it an arithmetic or is it a geometric, right? But then also I said you must find the number of terms, right? How many number of terms are there? You can say number of terms is upper value minus lower value plus 1. Right, your upper value is 70, but if you are starting from n is equals to 4, that's minus 4 and then plus 1. So how many terms are we dealing with here? How many terms are we adding to this series? So that's 70 minus 4 plus 1. This is going to give us 67 terms. So again, note, we don't have 70 terms. The 70 is the end index, but then the start index is starting from 4. So if we start from 4 and then we end at 70, there are actually 67 terms that we are adding. Okay, so now, number 2, write at least 3 terms. So how do we write at least 3 terms? Remember, start index is 4. So we have to start by substituting 4 here. So this means this will be your term 1 here. This is your first term. Then add 2 multiplied by 4 minus 4. That's going to give us 4, right? Then followed by what? 2 multiplied by 5 and then minus 4. So 2 multiplied by 4 multiplied by 5 minus 4, that's 6. Then we're going to have 2 multiplied by 6 minus 4. And then 2 multiplied by 6 minus 4, that's going to give us 8. Now from this, we can tell that the pattern that we have here is obviously an arithmetic pattern, right? Now it is easier to see that it's an arithmetic pattern because if you are to look at this, this is in the format of dn and then plus c, right? It's quite obvious, but then you still need to prove that by expanding at least to 3 terms so that you can be sure. Now, the common difference 4 to 6 is 2. From 6 to 8 is also 2. As we can see here, this is the common difference, right? So now that we have that, we are sure that this is an arithmetic series. This is an arithmetic series. So what we need to do now is to calculate the sum. So Sn is equals to n over 2, and then 2a plus n minus 1, and then d here, right? Now our n value is the number of terms that we are adding there. So we are adding 67 terms over 2. And then we have 2. Our a value, this is going to be this one here, right? So you see the importance of having to expand at least to 3 terms. We are able to see our a value. We are also able to see our d value. Then this is 4 plus 67 again minus 1. And then this is supposed to be what? 2. And then all you have to do now is simply punch all of this into your calculator. 67 over 2, and then bracket 2 multiplied by 4 plus 67 minus 1 inside the bracket, then multiplied by 2. So this is going to give us 4,690. Then just closer to that, you put your value there, right? So you will say this is equals to 4,690. Of course, you need to show all of these steps here. You can't just calculate by the side and then just write 4,690 and expect to get full marks. So we must see all of these steps. We must see you calculating the number of terms. We must see you at least expanding up until 3 terms. And then we must see you calculating the sum. And then at the end of the day, you just simply write this and say equal to 4,690. Right. Okay, so that's how you do it. Now, calculate the sum to infinity, right? So I've been waiting for this question. Now, how do you know that you must calculate the sum to infinity? At times you won't be told. They will just say evaluate from this point, right? Now, how do you know that you must calculate the sum to infinity? You must always check your upper value here. If on your upper value you have this sign here, which is for infinity, then this is obvious. It simply tells you calculate the sum to infinity, right? Now, obviously, when dealing with sum to infinity, you are not concerned about how many terms are there. How many terms are there? That's not the question that you worry about, because it's to infinite. You will never know how many terms are there in infinite. So that means you will just have to know your a value and then your r value, right? So your a and your r. Okay, so that means you will start by writing out at least 3 terms. Start by writing out at least 3 terms. Now, p is starting from 1. So 8 to the exponent of 4, 1 minus 1. So your value here will be what? So you just simply say 1 minus 1 is 0. 4 to the exponent of 0 is going to be 1. So your first term will be 8. Now, if you can just look at this, you can almost tell that this is in the format of AR to the exponent of n minus 1, right? But then let's continue having to do this. Then 8, 4. So we want to write at least 3 terms. So 1 minus 2. So that's 8, and then 4 here. And then we have to the exponent of, so 8 bracket 4, and then to the exponent of 1 minus 2. So the second term becomes what? 2, right? And then plus, to get that third term, so it's 1 minus the p-value is 3. So 8, 4, and then to the exponent of 1 minus 3. So we have our third term as 1 over 2. Now it is very, very crucial that you write at least 3 terms. Do not skip this step here, right? A lot of you end up having a wrong R value because you did not write at least 3 terms in order to find out. Now I want you to check something. You can assume that your R is 4. But then after doing this, you can see that your R is not equals to 4 because the format is Tn is equals to AR n minus 1. But if you can look at this format here, they wrote it in this format, AR 1 minus n, which is not the same. Not the same. So which is why the act of just changing the n minus 1 to 1 minus n also changes your r value. So it is very crucial that you write out at least 3 terms so that you can confirm what is actually your r value. And then this is r is equals to t2 over t1. It's supposed to be 2 over 8, which is 1 over 4, which is not that, right? As we can see here, this is indicating 4, but then actually our r value is 1 over 4. Now the a value, of course, it's 8. So we have 8, and then r is 1 over 4. Remember, we must calculate what? The sum to infinity. That's all we need. We need the value of a and the value of r to calculate sum to infinity. So we're going to say sum to infinity is equals to a over 1 minus r. Our a value is 8, and then we have 1 minus 1 over 4. Right. So this is supposed to give us 8, 1 minus 1 over 4. It's 32 over 3. 32 over 3. You can leave it like that as a fraction, or if you want to write it as a decimal, write to only 2 decimal places, which is 10.67, right? Either way, it is correct, whether you leave it as a fraction or you just decide to write to 2 decimal places. So, but then follow the steps. Number 1, write out to at least 3 terms, and then find your value of a, find your value of r correctly so, and then do whatever that you're supposed to do. Okay, so let's proceed. What is the value of m for which 5 times 3 to the exponent of k minus 1 is equals to 65, right? So what is the value of m? The m here is indicating what? This will be indicating the number of terms. The number of terms. In this case, we can see, yes, it will be indicating the number of terms because n is equals to upper value minus lower value plus 1. Your upper value is m, your lower value is 1, then plus 1, right? So negative 1 plus 1, your n is equals to m, right? So remember, this n here is for the number of terms, and the number of terms is equals to m, so that means m here represents the number of terms. Okay, so now what are we supposed to do? Number 1, write out at least 3 terms. Right. So 5, 3, and then your k starting from 1. 1 minus 1. Now 1 minus 1 is 0, 3 to the exponent of 0 is 1, and then our first term will be 5. Then followed by, we have 5, 3 to the exponent of 2 minus 1. And then this is 5, 3, and then 2 minus 1. This will give us what? So 5 times 3 to the exponent of... so this will give us 15, right? And then if we are to do it for the last one, 3 to the exponent of 3 minus that. So 3 minus 1 is 2. And then 3 to the exponent of 2 is 9. Multiply that by 5. It's going to be 45. Right. Okay, so we have 5, 15, and then 45 like that. Okay, so this will give us a sum of what? Of 65. So what we are supposed to do here, since we have found this, our a value, we can see it's equals to 5, and we can get our r value by simply saying t2 over t1, right? So which will give us what? 15 over 5. Now 15 over 5 will give us 3, right? So we have our r value, we have our a value. So this is supposed to be Sn is equals to a, and then we have Rn minus 1, and then r minus 1. The reason I'm using this one is because my r is greater than 1. So we say this is a convenient formula if our r is greater than 1. So, okay, I'm supposed to equate this to 65. So this is a, and then my r is 3 to the exponent of n, and then which is, I can say, since my n is equals to m, I can just replace it by m, and then minus 1 over 3 minus 1 is equals to 65. Now, okay, my A value, I already have it, is 5. Now, what do I do? 3 minus 1 is 2, right? Then I will take the 2 and cross multiply it with that. So 3 minus 1 is 2, and then 2 cross multiplied with the 65. We end up with 5, 3 to the exponent of m minus 1, and then 2 multiplied by 65 will be 130. Now I need to get rid of this 5. Divide both sides by 5. So 130 divided by 5, that's 26, right? So I will have 3 to the exponent of m minus 1 is equals to 26 from dividing by 5 here. Now I can say 3 to the exponent of m and take this negative 1 here over to the side, which will give me 27 if I add it to the 26. Now the 27 can be written in exponential form. If you say 27 equal and then shift factorize that, then 3 to the exponent of m is equals to 3 to the exponent of 3. Now the bases are the same. That means I can drop the exponents. My m is equals to 3, right? Of which, even if you were to check here, if you were to add all these 3 terms here, already at this point you can see that it will give you the 65. If you say 5 plus 15 plus 45, that gives you 65, which actually proves that we only need to add 3 terms of this series to get 65. But then this is how you are supposed to calculate that. So you need to at least show 3 terms and then find your A value, find your R value, then pull out the formula for some of the geometric series, and then calculate until you get to your value there. Okay, so let's proceed. Let's do another similar question. So again, we are looking for the value of m. The value of m, n is equals to upper value minus lower value plus 1. Your upper value is m, and then your lower value is 1, then plus 1. So meaning the number of terms is m. So the m that we are trying to calculate here represents the number of terms, right? So again, we're gonna first start by write out at least 3 terms. So we have 3 and then 2, 1 minus 1 here. So our case starting from 1, that's the start index. Then this will give us what? 3, followed by 3, 2, and then here we have 2 minus 1. So this will give us 2 minus 1 is 1. Then 3 times 2 is 6. Then we have 3, and then 2 here, 3 minus 1. 3 minus 1 is 2. 2 to the exponent of 2 is 4. 3 times 4 is 12, right? Okay, so we have 3, 6, and then 12, and then we must get to 93. So we have written at least 3 terms, which means our A value is 3, as we can see. And then how about our R value? It's T2 over T1, which is 6 divided by 3 will give us 2, which this one, because the format is quite exactly the same, we can see that our A value is 3 and our R value is definitely the 2 right there. Now, when you have this, you can now pull out the Sn formula. So it's Sn and then A, R to the exponent of n minus 1, and then R minus 1. We are using this one because we can see that our R is greater than 1. Our R value is 2. But then we must equate our Sn, A, R to the exponent of n minus 1 over R minus 1 to what? To 93. Because we are told that the sum of all this is 93. Now, what is your A value? You put 3 here. What is your R value? You put 2. And then your n here, remember, it's equal to m. So you can replace the n by m now. Then minus 1. So pretty easy to do these questions, guys. Then you have 2 minus 1 here is equals to 93. Now you have 2 minus 1 is 1. And then if you cross multiply it with the 93, it's still 93. So you have 3, 2 to the exponent of m minus 1. 2 minus 1 is 1. 1 multiplied by 93 is still 93. Then what do you do to get rid of this 3? Divide both sides by 3. Now, what is 93 divided by 3? That's 31. So we have 2 to the exponent of m minus 1 is equals to 31. Now, if you take the negative 1 over to this side, you'll have 2 to the exponent of m is equals to 32. So now you are supposed to write the 32 in terms of exponents, right? You have to write the 32 in exponential form, and it must have base 2 so that you can apply the law that says if the bases in an equation are the same, you can drop the exponents. So this is 2 to the exponent of m. Shift fact the 32, then it will give you 2 to the exponent of 5. Now the bases are the same. That means you can drop the exponent. Your m is equals to 5. Right. Now, let's say we want to prove that we really need to add 5 terms in order to get 93. Remember, we had our first term as 3, then followed by 6, then followed by 12. Seeing the trend, we do understand that in order to get to the next term, we just simply need to multiply by 2. So that means we'd have 24. If we multiply this by 2, we have 48. So how many terms are there? 1, 2, 3, 4, 5. Now, this is saying if we add these 5 terms, we are supposed to get the 93. Is that true? Let's say 3 plus 6 plus 12 plus 24 plus 48. And then voila, exactly we get 93. So we have found that the number of terms that we have to add into this series in order to get 93 is 5 terms. Okay, so that's it for your sigma notation.